reason that this meeting exists is for the next section. When we wrote the grant that the NLM currently funded this work with, there was a requirement for how are you going to disseminate your findings? And we didn't really want to go to meetings or say we had to publish papers or do anything like that. So we decided instead of, having to write a paper and get it accepted someplace and then go there to present it, we just invite the audience here to hear it. So we decided to have this meeting so we could present this data at a scientific meeting. And then we said the NIH should pay for the meeting. So it was a good idea. I only mention it because everybody ought to try the same trick because they funded at least 50% of the cost of this meeting. And they count this as dissemination of our at least preliminary results. So we are today, remember I could dig up a slide and talk about the steps that we think were necessary for meaningful use of medical data. But they were basically get hold of the data, curate the data, put it in this format in which it can be, knowledge discovery can occur in the data, and then analyze the data and bring it back to the bedside. We've taken steps in all of those areas. There were 3 specific aims that broke that up, but the approach was pretty widespread. And we've done some work in all of those areas, and we're going to start with the first area first, getting the data, putting it in a reasonable architecture, and starting to curate the data. And I'll stop there and introduce Andrew Hart, who's been working with JPL and with us on this since we started off on this grant. So, Andrew, welcome.
Thanks very much. So as Randall mentioned, and as the discussions yesterday have sort of laid the overview for what the VPICU is and what we're trying to do. So I'm going to just discuss the architecture behind it. And you remember, those of you who were here yesterday, Dan Crichton's discussion of scientific data systems and some of the work that's being done at JPL and the overlap between what they are trying to do for things like planetary research and what we're trying to accomplish here for the VPICU. So hopefully you'll see some similarity between the high-level concepts that were discussed yesterday and then what we're discussing today as we apply it to the VPICU data system. These are essentially the high points I want to hit today. Just discuss the architecture, discuss some of the decisions that informed the choices that we made, and then at some point going to have a little portal demonstration by Paul V, who's going to just take us through an initial prototype of what we imagine one of the potential end uses for this being. So to just recap, what Randall brought yesterday was essentially the vision of VPICU at a really high level is to improve the amount of data and the quality of the data that's available for decision making and available for the purposes of providing better care. Essentially, it's a data-driven approach. And we also have touched in a couple of different places about some of the challenges that are unique to the data that we have to deal with in the VPICU. And chief among those is the fact that we're not the primary reason the data exists. In fact, we're using this as secondary use data. It's collected for clinical purposes, and we want to use it for research. It hasn't been created for that purpose, and we can't even use traditional select star approaches on operational databases because they're operational, and we would not want to endanger that. And so essentially what I'm laying out here is the reason why we actually need an architectural approach to this, and we can't just simply say, well, there's data here and there's algorithms here, and I want to combine them and get something out. There needs to be a bit of a principled approach because the data is not ours, so to speak. It comes from many data sources and technologies. Those of you here yesterday will remember the CIO's talk where he showed that rather bewildering chart of all of the different data sources and the difficulty that they're having in mapping the meaning of the data to each other. And again, we have to deal with proprietary formats, individual vendors, conflicts, and the fact that some of them are not interested in us having the data for research purposes. If and when we do get the data itself sometimes exists over periods of years, decades even. It represents an incomplete record. There might be missing data. We've talked about some of that. And even if it's there, the language or the terminology used is often inconsistent, and that can cause some issues. And then, of course, with health data in particular, it's very heavily restricted, and especially for research purposes, there are all these other considerations that are important. So I guess if you were looking at an ideal research data set, the VPICU research data is in almost every dimension, would not meet the characteristics of an ideal research data set. But this is what we have to deal with. So with that in mind, we took some of the lessons that we've learned at JPL for building scientific data systems, and some of them are generic and applicable here, and some of them are actually really important for what we're trying to build here, which is essentially a platform for making clinical pediatric data more available for research purposes. And this is a platform that, while it's starting at CHLA, the ultimate vision for it is that it can become more of a national network of data sharing where what is done at CHLA can be replicated across more than just one PICU. And so with that in mind, I'm just going to run through these relatively quickly. The idea of loose coupling is, I believe, really important, and I think we've all seen situations where there's a silo or a stack of vertical things where if you make one decision in one area, it affects the decisions or it constrains the decisions that you can make in other directions. And I think that if you're going to build a system that needs to evolve and needs to be able to scale, a loose coupling of the individual components such that everything does its own job is a critical prerequisite. Likewise, a distributed deployment, the ability to not require that everything must be existing in the same rack or in the same hospital, is also a critical piece. We really want to try and build a more federated approach to this where everybody's using a common information model to help provide consistent annotation and consistent definitions for the data that help facilitate its sharing. And in a system like VPICU, extensibility, scalability, security, these are important characteristics of just about any scientific data system. But what's important, I think, for this is that we're building this in 2011. And the vision is that this doesn't just solve today's problem, but that this begins to be a repository for pediatric data that then begins to be the formation of a long-term data archive. And so we don't know what questions we ask of it today may not be the questions we ask of it in 5 years or in 10 years, but the data needs to be there. And so we need to be able to have a system that can be extended upon and scale. And then, of course, again, with the health data, the security issue is just critically important. And with that same thought in mind, technology independence is very important. There's the concept of a separation between the information model, which describes the data, and the technology implementation. Again, in 10 years from now, the decisions we make today about how to actually realize this architecture may look antiquated or may not be what is necessary in order to cope with the volume of the data or the complexity of the queries. And so the blueprint, the architecture for the system needs to be able to separate the information model from the implementation and allow evolution as technology dictates. And then the last thing is, and this was talked a little bit yesterday with Chris's talk, the importance of open standards for the purposes of avoiding vendor lock for one, but also for the purposes of being able to integrate and take advantage of tool support that may already exist so that you're not stuck reinventing the wheel in areas that you don't necessarily have to. So these principles were sort of in our mind and informed what we were trying to do as we were coming up with a design for this architecture. And so we've taken a systematic approach, and Randall actually laid it out in his introduction very well. We basically moved from getting our hands on the data, right, getting an understanding of what data is available to us. And this is an information model of sorts that is an iterative thing because, again, we don't know exactly what we're going to have, and it's presumptuous of us to expect that we have the ultimate model for this information. However, it is important to have a model that can inform each of the stages of this. We wanted to develop compute services that could take the data out of the existing databases. I think Jeff Hammerbacher said this really well yesterday. He said, just get the data. Just get the data and make sure you have it. So you don't wait until you've figured everything else before you start getting the data. Randall has said again and again, the data exists. It's there. It's just not being used to its full potential. So this is a big portion of this system as a whole, is to try and increase the amount of the utility of the data that's already available to us. And with that in mind, we wanted to identify mechanisms to integrate this data as it currently exists in its various operational clinical databases into a common repository that has some degree of standardized metadata that makes it easy for an outside observer to say, I understand what exists, or I can see how I could learn more about this because this is the common information. And from that, ultimately, we have a repository of data that represents maybe years, maybe decades of clinical patient data. The ultimate goal, though, is to be able to construct more purpose-driven, more specific structures for then asking direct questions of the data, and generally with a research purpose in mind for doing mining and analysis. And then ultimately the goal is then to be able to take what we have hopefully successfully built at a hospital like CHLA and include features for connecting a PICU across another PICU and basically doing the external communication and replicating what we're trying to do to make even more data available for research purposes. And I'm not actually going to talk about this last one, but what we are trying to do is provide an environment in which services and algorithms and approaches for mining and making sense out of this data can be executed. And so the person who's going to follow me, Dave Kale, will talk about some of the efforts that we've done in that direction. And then ultimately scaling it across the PICUs is a long-term goal of this project. So I've said that a couple of times with an information model, and we just got done hearing about ontologies. And I think from our perspective, we call it an ontological representation, but we're actually really interested in making sure that the data we get can be annotated with standard metadata. We're not trying to take it to the level of doing inferences yet. That is down the road. But what we really want to do is take what we don't have at the moment, which is if I look at 4 different database schemas, I have to really have an intimate knowledge of each of these operational databases. And we want to be able to provide through this, there are some abstract concepts at a very high level that are consistent across all of these data sources. And we want to be able to provide an outside observer with the ability to come to the system and say, I'm interested in this in general, and sort of have a tiered approach that they can get more and more information about this. And so what we describe in our information model is a high-level picture of concepts like an intervention, an outcome, a patient, a clinician, and the relationships between them so that somebody looking at this system can have a sense at some level of what questions they can expect to ask of the data. Sure.
When you think of a high-level ontology that carries through, can you also provide a system for something, for example, topic-based or other dynamic ontologies that could be computed on an ongoing manner, automatically?
Well, I think that that's definitely part of what we want to try to do. I think what we're doing at the moment is exploring, essentially, to see what we can start with. As we get more confident in what we're doing and have a better sense of exactly what data we're dealing with, the abstractions that are involved in what you're talking about will become more apparent. So the last thing I was just going to say about the information model is that in addition to the concepts, we wanted to start defining essentially a data dictionary that helps mitigate some of the terminology differences that you inevitably encounter when you, certainly even within an institution, if you've got different data sources, they are saying the same thing with different terms. And so for the purposes of being able to come into the system as a user and say, I'm interested in blood pressure, where some people have encoded it as BP and some as systolic, I mean, that is a wide-ranging thing. So part of what we're doing is iteratively building up a data dictionary that helps us achieve some level of standardization that, while not perfect, represents an improvement over having to understand the detailed schemas of each of the individual data sources. And so this model infuses each step of the architecture, which I'll go through, and it really is what enables our approach of using loosely connected components, is because they communicate with one another along defined interfaces and a standard vocabulary. And we feel that this is also critical to being enabling what we would call a long-term archive, because at some level, just like a library, you have to have a classification system. So the architecture is what really I'm getting to here, and I'm going to put up a big diagram here that might be a little bit overwhelming from first glance, but it really represents a lot of thought into what we were trying to do. And again, just to summarize, we're trying to take operational clinical data, make it available in some form of generic representation with an information model that helps us understand what we've got, and then from there pick and choose what subsets we need to do really research-specific, purpose-driven databases from which we can query, do visualizations, do analysis, and move forwards from left to right. So I'm just going to step through this step by step. The first principle really, as we mentioned earlier, was decoupling ourselves from the proprietary databases. If you're creating a long-term record, we can't guarantee that in 10 years the same databases are going to exist in their same format. We want the data. We want the data, so we need to get our hands on it and make sure it's in a format that is relatively consistent. Even at CHLA, there are databases that represent data from decades ago, but that are no longer actively being changed. And if somewhere in the future someone decides there's no more funding to maintain that, we wanted to make sure that the system has that data regardless of what happens to the original data source. If you start moving, so where does it go? Once we pull it out, where is it going? And so this is essentially the crux of our long-term archive, and it's stored in a technology neutral a format as possible, and it's essentially a collection of hierarchical flat files. It's not an SQL database. It's not something that potentially will become obsolete. I mean, this was essentially our thing. It's not yet optimized for any kind of research, but it is as close with minimal transformation as we could do, close to extraction from the original data source. And so we've separated the question of extracting data from the upstream sources and preparing it for research, so that we, in the middle, end up with this intermediate data store that represents a comprehensive set of the data that's actually available from the PICU. Getting it to a stage that's ready for research involves essentially what we've been calling computational workflows, which in computer science can be expressed as a graph, essentially a set of sequential tasks. Each one takes an input, performs some transformation, returns an output. And you can chain these together as needed to provide essentially a pipeline of data transformations. Some of the simple tasks could be de-identification, deduplication, normalization. Some of those are actually very similar. You might need them again and again. And so part of this has been to develop a repository, not just for data, but also of common transformational tasks that you may wish to use to operate on your data. And so the idea is that once you have this essentially rich, relatively standardized repository of data, you can begin to use these tools to ask of that data, because it's aligned to this common model. You can pick subsets of that data, perform some alignment, some transformation, some de-identification, and prepare it then for an output as either more flat files, let's say something as simple as a comma-separate value dump or a JSON file dump, or begin to build up more complicated data structures such as an SQL schema, depending upon the needs of your research question. And so the point is that everything to the right of that big repository is done with a particular question in mind. And once you have these research databases, as we're calling them, which may again be as simple as a couple of files that you would download, but they're specific to a research question, the question then becomes, how do I get access to this? And this is something that we've only recently started to address, because believe it or not, it did take an awful long time to figure out some of the early stages of this, especially keeping in mind our desire to make sure that while this was specific to CHLA and CHLA data needs, it was also sufficiently generic that it would be extensible at some point to realize the vision of multiple connected PICUs. So we've essentially punted on the decision of what's the best way to get it to you by offering as many and as flexible options as we can. A number of traditional sources might be through a data portal, essentially something that allows secure role-based access to the resources of a particular PICU and to the computational abilities, and so that a researcher can come in and take a look at what resources are available, what data sets have been generated by other researchers, and so on. And that is actually what Paul is going to demonstrate in a little bit. We also have talked a little bit about options for essentially direct access, either language-based or to ignore or to avoid the appearance of being favorited to a language like R or MATLAB, using RESTful web services, essentially something very much like Jeffrey here discussed, where his data sets actually have a URL that can be can be accessed. I mean, having direct language agnostic access to specific data is something that I think is very valuable. So we've taken the architecture from silos of independent, non-communicative data, and we've generalized these things, or extracted them and aligned them to an information model that provides a long-term scalable storage. Then we've used purpose-driven specific workflow tasks, chains of individual computational units, to build the equivalent of a data set or a database of research-oriented data that can then be accessed either through the web or through direct programmatic libraries. So I think to help make some of this real, we're going to show essentially one version or one vision of this of the right-hand side of this architecture, which is the portal for accessing and getting a sense of what's available. And Paul V is going to demonstrate the portal prototype that we have for the CHLA PICU based on the research data that we've already run through this system. So if you want to go ahead and do that.
Thank you, Andrew. So how do I get out of here? Okay, so this is a prototype of our portal to the data that basically what Andrew was just talking about. So I'm going to give you a visualization of that. So basically pretend I'm a researcher here at CHLA. I'm logging as R. Wetzel.
Okay. What was the password?
Wetzel.
The site's going down.
So basically, the way I'm going to run through this demo is basically I'm going to go from the bottom to the top. So the first thing we're going to talk about is the HD Explorer, which is basically what Andrew was talking about, getting the data to its most generic form. So let me go ahead and click on that. And so basically what we have here are the different data elements that we have taken over from the far left-hand side that you saw from the diagram and into these generic sort of, and the way Andrew explained them, they're actually files. So there you go. So this one is called PICU patient admissions raw data. As you can see, they're all text-based. So basically, these were just dumped over here, to the HDP, and by clicking on additional information, you can see the metadata that was around there. You can actually see that, as a researcher, you can see what attributes were in this data set. So you have, unit number, origin, referent, all that information is here. So how does it help the researcher? Well, as Andrew's saying, is that when you go from the HDP using workflows, say a researcher wants to learn or wants to create some kind of sort of data set, you would have to go through a workflow. Here we already have a workflow created called clustering preparation. So this workflow is designed to combine data from two major sources of PICU data at CHLA. So as a researcher, you can either look into its details, publish it, or actually run it. So since we already have this already created, let's take a look inside. So as Andrew was saying, these workflows are essentially a lot of tasks. So, and our hope is that these tasks can be reused for other workflows. So for instance, chunk by patient. So this will break up each ISM chart event into a parameter. And then hopefully when another research comes by, they can reuse these when we create new workflows. So what happens when you run through all these workflows? You get your data set. So by having this workflow, we have two data sets. We have the cluster preparation outcomes data and the demographics data. So at this stage, a user can actually either download the data, or they want to learn more about it or forgot what was in there, can click on the details and see exactly what's in there. So the top row, you see that the data consists of demographic data, which is gender, race, age, weight, height, and head circumference. So that was actually from that, this data set was created from that workflow. So then what we did is just made some simple graphical visualization so users can actually see what's actually in this data set without having to download the entire data set. So you can see here we have a male, female, gender, race, age, and weight. And we also were looking forward to actually creating metadata around the users as well, because we have, obviously this is just a prototype of the first version, but going forward, we would have to make this multi-institutional as well, so there would be some sharing and whatnot. So that's pretty much the demo, and I'll bring Andrew back to complete this stuff.
As Paul is saying, this is obviously prototypical, and this is just something to prove the concept that there is a way to get that the information model that we've been talking about is actually very important when it comes to looking at data that you didn't have control over. For those of you not at CHLA, this might have given you at least some sense of, well, what data are they really collecting here? What data is really available for research, and am I interested in it? What is the breakdown of patients, or what are the attributes that are available for me to include in my data sets? So, as again, this is a high level demo. If there are questions about it, we're happy to take them just as soon as we wrap up, which I'm doing right now. The sort of condensed statement of everything that we're trying to do here is the development of a long-term archive of data and metadata, PICU patient data from multiple upstream sources. And we want it in such a format that it's suitable for transformation into data sets and databases that are then purpose-driven for a specific research question. And the way that we're accomplishing that is through these composable, reusable computational workflows. And at the same time, from an even larger zoomed out to even bigger, is that this NLM investment in the grant that has funded the partnership between JPL and CHLA has resulted in essentially a lot of effort gone into an architecture or a way to think about a platform for conducting this type of data data gathering, essentially, and providing this platform for the analysis that supports analysis activities like we're going to hear about next, and then ultimately with the vision of taking what we've done here and replicating it across more than one to even further extend the volumes of data that are available for this type of research. So the immediate next steps for a system like this would be to take what we've already done and shown here, essentially with 3 existing CHLA data sources, improve it by adding to the number of data sources that are available, improve the amount of workflow capability that we can support, and basically making the system easier both to manage and configure so that you don't need somebody like a JPL to come in and help you set this up. And then ultimately the next step down the road would be to support the federation aspects of the system so that we can do researchers at a particular PICU are not limited to the data that is stored within their institution, but can yet rather use this as a resource for accessing additional sources of data and basically start to reuse data and effort. So that's all that I have, but I'm happy to take questions at this point.